to the 2014 Charles Stark Draper Prize for Engineering celebration and recognition of the awardees. We're very fortunate to have moved this party back to the National Academy of Sciences building, and this space is sort of like being in church in some way. This is almost a religious experience being in this space. If you look at the ceiling, and you can see all the history of science that was recognized in 1923 when this building was built. And so therefore, I love this space. Among all the spaces there are in the National Academies, this is the premier space. So moving this event to this space, I think is very special, and I hope you appreciate it as much as I do. So tonight we're going to recognize, of course, 4 distinguished winners of the Charles Stark Draper Prize for Engineering. John B. Goodenough, Mr. Yoshio Nishi, Dr. Rashid Yazami, and Dr. AKIRA YOSHINO. And you'll hear a lot more about them in a minute, but now it's time to eat and drink and really enjoy yourselves, because this is supposed to be fun. Actually, this is supposed to be fun. So until we start the program, which will be about 8:30, you get to eat and really enjoy your colleagues at the table. So thank you very much for coming tonight. It's all our great pleasure to have you here. Well, good evening, everyone. I think we are now arriving at the very special moment. And before we start the presentation, I would like to, following our tradition, to acknowledge just a few people here who have come here tonight. And of course, everybody is special, so please don't feel disappointed if you're not acknowledged, but consider yourself acknowledged in any case. We have, of course, a strong partnership with the Charles Stark Draper Laboratory, and tonight we have with us Frank Miller. He's the chairman of the board of directors of the Draper Lab, and he's independent consultant and a principal of the Scowcroft Group. So he'll be part of helping us in this ceremony. We have Ambassador Rashid Bouhalo of the Embassy of the Kingdom of Morocco is with us tonight. Mr. Ambassador, welcome. We have Akira Tsukita, the Science Counselor of the Embassy of Japan. Tsukita, thank you very much. We have Ralph Cicerone, President of the National Academy of Sciences, and his wife Carol Cicerone, Dr. Carol Cicerone. Ralph, wherever you are, there you are, thank you very much. We have Harvey Feinberg, President of the Institute of Medicine, and his wife, Dr. Mary Wilson. Harvey, thank you very much. Now we have representing the 2014 Engineers Week co-chair, Ellen Kuhlman, who is the CEO and chair of DuPont, who is not present tonight, is Karen A. Fletcher, the chief engineer and vice president of engineering, facilities, and real estate at DuPont. Karen? Thank you very much. And we have a number of previous recipients of the Draper Prize. We have members of the Draper Prize Selection Committee, and we have members of the National Academy of Engineering Council, and we have family members and friends and colleagues of this year's Draper recipients, and we also have my wife, Patsy. Will all of you please stand to be recognized? What? Well, Patsy's standing anyway. I guess everyone else is just too shy. I can guarantee she's not shy. I'd like to welcome to the podium the National Academy of Engineering Council Chair, Charles O. Holliday, Jr. He's a retired chairman of the board and chief executive officer of DuPont, and who will co-officiate the ceremony this evening. So Chad, I'd like to turn the podium over to you, if I have this straight. Thank you very much.
Thank you, Dan, and welcome everybody. This is the world's most prestigious award for engineering. The Charles Stark Draper Prize honors engineers who've made the most significant contributions to innovations over our time. There have been 44 winners of this award, And tonight we are extremely proud to add 4 more to that group. This is a very special time for the award, our 25th year. So we are so glad everybody could be here and we could have this in the home of the National Academy of Sciences, National Academy of Engineering. Let's take a look at a video now that will describe Doc Draper, the person this award honors, and our newest winners. Let's roll the video, please.
25 years ago, Draper Laboratory joined with the NAE to establish the Draper Prize for Engineering as a way to honor the legacy of our laboratory's founder, Dr. Charles Stark Draper. The prize publicly recognizes the engineers responsible for the technology developments that have transformed modern life and significantly improved the well-being and freedom of humanity. Doc was a great educator who trained generations of students at MIT. His belief that engineering education needed a hands-on component led him to establish the instrumentation laboratory within MIT's Aero department. In 1973, the instrumentation laboratory divested from MIT to create the independent, not-for-profit Draper Laboratory that today is recognized as a world leader in guidance, navigation, and control. Doc's ultimate goal was to solve the nation's most challenging technical problems. Since his death, Draper Lab has built on his vision of demonstrating first-of-a-kind solutions to these challenges. We have continued his hands-on approach, but expanded our capabilities beyond guidance systems. We now produce functioning prototype solutions for problems in domains ranging from space and security to healthcare and energy. We pioneered the development of micro-electromechanical systems, or MEMS, designing the world's most accurate MEMS gyros and accelerometers. Staying true to Doc's legacy, we have applied the same technology to innovations in chemical sensors and tissue engineering and become world leaders in vanishingly small electronics and autonomous unmanned systems. When asked by a reporter what his laboratory had done differently than others that led to its immense technical success, Doc replied, "We simply made things that worked." It is that spirit of producing working solutions rather than theoretical discoveries that the Draper Prize for Engineering honors in its recipients. Over the last 25 years, the Draper Prize for Engineering has been awarded to 46 engineers for their work on 19 separate technologies. Some of these technologies have become their own multi-billion-dollar consumer industries, like GPS, cell phones, the personal computer, and the internet. These are household names, and their role in society is well established. But for accomplishments that earn the Draper Prize, we measure impact, not notoriety, when judging their importance. For example, the Kalman filter has been a critical part of guidance, navigation, and control of air and spacecraft since Apollo. Directed evolution is the cornerstone of the entirely new field of protein engineering, which enables the creation of specific proteins with defined qualities, such as thermal stability or catalytic activity. Corona ushered in the era of satellite reconnaissance for national security, even though its work was classified for nearly 4 decades. For these past 25 years, the Draper Prize for Engineering has given us the opportunity to reflect not only on the developments that have initiated technical revolutions in areas as broad-reaching as communications, computing, transportation, and bioengineering, but to honor and celebrate the engineers that have made these revolutions possible. Without these remarkable individuals, much that we take for granted in our day-to-day lives would not exist. The 2014 Draper Prize for Engineering is awarded to YOSHIO NISHI, John B. Goodenough, AKIRA YOSHINO, Rashid Yazami for the development of the lithium-ion battery. On behalf of Draper Laboratory, I congratulate these winners and look forward to the continued growth and evolution of this remarkable technology.
John Holdren, I believe you're here tonight. Could you stand up, please? The President's Advisor on Science. We're extremely pleased that Mr. Frank Miller, the Chairman of the Board of Directors of the Draper Laboratory, can be with us tonight. let me just say a word about Frank. He spent 31 years serving this country, Department of State, Department of Defense, and in the White House as Special Advisor to the President. He's been honored by Norway, France, and Britain for his outstanding service. I think more important is he's received the highest civilian honor for serving in the Defense Department, Distinguished Civilian Service Award, 5 times. So Frank, we're so glad. Would you please join us at the podium? Dan, the floor is yours.
Well, thank you, Chad. The recipients of the Draper Prize share $500,000 prize award, and each receives a commemorative medallion and a kind of hand-lettered certificate as well. In addition, on behalf of the Draper Laboratory, the recipients are invited to a lecture at the Boston Museum of Science at an event this spring. The 2014 Charles Stark Draper Prize for Engineering recipients, Dr. John B. Goodenough, Mr. YOSHIO NISHI, Dr. Rashid Yazami, and Dr. AKIRA YOSHINO, their citation reads as follows. For engineering the rechargeable lithium-ion battery that enables compact, lightweight, mobile devices. The lithium-ion battery is used by millions, if not billions, of people around the world in cell phones, laptops, tablets, hearing aids, cameras, power tools, and many other compact, lightweight mobile devices. In 1979, John B. Goodenough showed that by using lithium cobalt oxide as the cathode of a lithium-ion rechargeable battery, it would be possible to achieve a high density of stored energy with an anode other than metallic lithium. This discovery led to the development of the carbon-rich materials that allow for the use of stable and manageable negative electrodes in lithium-ion batteries. Shortly after Goodenough's breakthrough, Rashid Yazami began exploring graphite compounds in which lithium could be reversibly inserted between graphite layers. This provided an alternative to the lithium metal negative electrode. Yazami's lithium graphite is the most commonly used anode in commercial lithium-ion batteries today. In 1985, Akira Yoshino produced a rechargeable lithium-ion battery prototype using a lithium cobalt oxide cathode and a carbon anode, eliminating metallic lithium. This design significantly improved the safety of the battery while also providing practical energy output at a reasonable price. Yoshino's work resulted in the first safety-tested, commercially acceptable lithium-ion battery. Yoshio Nishi served as an operating officer and senior manager of SONY Corporation, where he sought to make the lithium-ion battery a household item. After overseeing the development of the quality controls and the safety characteristics necessary for mass producing the battery, SONY officially released the high-performance lithium-ion battery into the market under Nishi's supervision. The economic impact of the lithium-ion battery is now estimated at approximately $10 billion per year. Dr. John B. Goodenough began his career at the Massachusetts Institute of Technology at Lincoln Laboratories in 1952. After leaving MIT, he became professor and head of the Inorganic Chemistry Laboratory at the University of Oxford. During this time, Goodenough made the lithium-ion discovery. In 1986, he took the Virginia H. Cockrell Centennial Chair of Engineering at the University of Texas at Austin, where he currently works and continues his research. Yoshio Nishi is retired Senior Vice President and Chief Technology Officer of the SONY Corporation. In addition to these roles, he also held the positions of Executive Vice President, Corporate Research Fellow, President of the Materials Laboratory. Nishi joined SONY immediately after his graduation and was engaged in R&D on fuel cells, materials for electroacoustic transducers, electrochemical cells with non-aqueous electrolyte. Now, Rashid Yazami began his career in France at the Grenoble Institute of Technology and at the CNRS, the National Scientific Research Laboratories in France, where he later became a research director in 1998. While working at CNRS, Izami also served as a visiting professor at Caltech between 2000 and 2010. In 2010, he was appointed as visiting professor at the Nanyang Technological University in Singapore, where he later became the Chong Zhang-man Chair Professor of Energy at the School of Materials Science and Engineering. In 2011, Izami founded a startup company in Singapore, KVI PTE Limited, dedicated to battery life and safety enhancement for mobile electronics, large energy storage, and electrical vehicle applications. Izami is also a founder of the CFX Battery Inc., now Contour Energy Systems, a primary and rechargeable lithium and fluoride battery startup company in Azusa, California. AKIRA Yoshino conducted his research on rechargeable batteries after joining the ASAHI KASEI Corporation in 1972, where he currently serves as a fellow and general manager. Over the last 40 years, Yoshino has served in numerous positions and has worked in several laboratories at ASAHI KASEI. In addition to his current roles, he is also president of the Lithium-Ion Battery Technology and Evaluation Center, LibTech. We'll have a quiz on this, by the way, right after dinner. Now I would like to ask the winners to come up to the podium as your name is called, to receive your award. And let's see here. Okay, we'll I'll start with your name. John B. Goodenough, would you please come forward? Now, Mr. Yoshio Nishi, next, please. So Mr. Dr. Yashid Izami. Rashid Izami. And Dr. AKIRA YOSHINO.
Tonight, the National Academy of Engineering celebrates the role in society of materials engineering. We four are delighted and honored to participate in this celebration, and we are grateful to all those who have contributed intellectually, financially, and as colleagues to our presence here. The lithium-ion rechargeable battery illustrates the complex process of innovation in materials engineering, and the importance of both the support of the individual investigator and the availability of open international communication between scientists. In the early 1970s, there was a confluence of several events that led to the technology we are celebrating tonight. First, the first energy crisis alerted the developed world to its vulnerability to dependence on imported oil. Second, the 3 Mile Island incident helped to expose the limitations of nuclear energy. Third, explorations by Jean Rouxel in France and Robert Schulhorn in Germany of the chemistry of reversible lithium intercalation into the layered compounds, particularly the sulfides, led to the suggestion by Brian Steele of England of a rechargeable lithium battery having TiS2 as its cathode. The lithium TiS2 battery was abruptly abandoned after incendiary cell failures that resulted from internal short circuits by dendrite growth from the metallic lithium anode to the cathode after repeated charge-discharge cycles. My contribution was to realize that an oxide cathode could provide a higher voltage and allow the use of a lithium-free anode in the fabrication of a discharge cell. This realization led to the development of lithium cobalt oxide cathode in my laboratory at the University of Oxford. Quite independently, Rashid Yassami was exploring in Switzerland lithium intercalation into graphite, a process he found did not result in dendrite formation, providing the charging rate was not fast enough to plate lithium on the surface of the graphite. In Japan, Akira Yoshino, again quite independently, then understood he could assemble a rechargeable discharge cell with a lithium-free graphite anode and a lithium cobalt oxide cathode to create a safe lithium-ion rechargeable battery. Yoshio Nishi of the SONY Corporation Japan used this battery to develop the first wireless telephone. With a marketable product, the wireless revolution was born. The batteries of the wireless revolution do not have to compete with the energy stored in fossil fuels. Today, the engineering challenge is the development of electrochemical devices that will enable electric vehicles and also the storage of electrical energy generated from wind and solar energy at a cost that is competitive with fossil fuels. This challenge remains an urgent global priority for a sustainable modern society. Thank you.
As you've just heard, the work of these four great engineers has not only changed the life of everybody in this room, but changed the life of virtually the 7 billion people on the planet. Would you please join me in a standing ovation to these great individuals?
Well, it's a breathtaking evening. I really hope you have enjoyed honoring these winners. It's like Olympic Games. It's the kind of the gold medals, really, of our profession. And I thank everyone who participated with us this evening and joined in celebrating the Charles Stark Draper Prize for Engineering. Now, to commemorate our 25th anniversary of the Draper Prize, we have left a small takeaway at your seat, a power bank for your electronic devices. Please enjoy it, and you can think of our award winners every time you recharge your devices. In more ways than one. So now, please join us in the West Court where we had the cocktails before, where the dessert will be there, and we can mingle and we can speak with our award winners and just enjoy the rest of the evening. So thank you very much for coming for the dinner. I hope you've enjoyed it as much as we have.